Okay, this is section 3.1. We're going to look at this section quickly. Before I do, I want to, again, review just the different things we've learned about properties of triangles. Okay, so I'm just going to erase these lines here. So, really, we've already learned about three main things in each one of these triangles. We've learned about what a median is, what an altitude is, and what a right bisector is. Who can tell me what the definition of a median is, just in your own words? What's a median? Yeah, Kyle.
A line from a vertex to the midpoint of an opposite side.
Yeah, not vertex, but vertex. Yeah, line from a vertex to midpoint of opposite side. Good. Altitude. A little harder. All right.
The straight line from one point to another point. That is.
Okay, that's a definition of a straight line.
A line going from a vertex to the opposing line that meets at a right angle.
Good. So line from vertex to opposing side at right angle. Okay? So a line from vertice to opposing side at a right angle. Okay, and the last one, right bisector, Jonathan?
I have no idea.
No idea? Come on, what a right bisector is? Okay, think about the word. What do you think bisector means?
Bisect something?
Yes, good. So when it bisects something, what does that mean?
It crosses something?
What does bi mean?
Two?
Two, good. So when you bisect something, you're going to divide something into
Two?
two equal parts. Good. So we're looking at a line because both of these are lines. So right bisector is also going to be a line. So a line that divides something in two. And then what does right mean?
Right?
Yeah. So when we're talking about triangles, we're talking about a right angle. What's that? What is a right angle?
90 degrees?
Good, 90 degrees. So can you put that together, your definition now?
Two lines that bisect at a 90 degrees angle.
Okay, close. Someone else want to help him out? Dominic, yes.
A line that splits two lines in half at a 90-degree angle.
Good, yes, perfect. So it's a line
Hey Tom, nice one.
that crosses midpoint of another line at a 90-degree angle. Okay, so Jonathan, you're expected to know this now. Okay, this is old stuff, right? This is from chapter 2. So now we're moving on, and we have a couple of other things we're introducing. Concurrent just means that they meet on a single point. You've heard the expression, I concur, I agree, we're in sync together. We're on the same point. That's concurrent. Centroid is the point where the three medians of a triangle intersect. So just before we do that, I'm going to draw the medians now. So let's do a median from B. So from B down to the midpoint of the opposing line, or the opposite line. Okay, so this is midpoints now. Or sorry, medians. This is median from C. So from C to the opposite side, midpoint, and from A to the opposite side, midpoint. Okay, those are your medians. Your altitudes, I'll draw over here, are from a vertice straight down to the opposing line. So it comes straight down. If the line is outside the triangle, you need to extend the line and draw a 90-degree angle. Okay, that's your altitude from D, your altitude from F. So it's going to be F. You want to be 90 degrees. This is going to extend this way. So that would be your altitude from F. Okay, so again, the opposing line is extended to meet the altitude. And finally, from E, that's your altitude. Okay, so this is median. Here's your altitude. And finally, your right bisector. I've started to draw them here. See if I can draw them a little bit more accurately. There's your midpoint. Midpoint here. Midpoint here. Okay, so this is your right bisector. So it's dividing a line in two equal parts and crossing at a 90-degree angle. Oh, there's whispering going on. Is there a question?
No.
No? Okay, so we understand now what a median, an altitude, and a right bisector are. Now we want to learn what a centroid is. So a centroid is defined as the point where the three medians of a triangle intersect. So again, the centroid here would be this center point here. This is your centroid. Okay, our circumcenter is the point where the three right bisectors of a triangle intersect. So that's this point here. This is circumcenter. All right, and circumcenter can lie outside the triangle or inside the triangle, whereas a centroid is always inside the triangle. If I were to draw the circumcenter for this triangle, crossing through the midpoint at 90 degrees, it would be right around here. This would be circumcenter. Any questions so far? Okay, so the key concepts for section 3.1 is that we're looking specifically at an isosceles triangle. Okay, and if we look at an isosceles triangle, as we know, an isosceles triangle has two sides that are equal. These two sides are equal. What we find out then is the median, so from the vertices to the opposing midpoint, opposing side midpoint, ends up being the right bisector as well. Okay, so that's a unique property of isosceles triangle, is that the median from the vertice between the two equal sides, in this case A, the vertex A, ends up being the right bisector. The medians of a triangle meet at a center point. The center of each median bisects the area of the triangle. And finally, the last point we just want to point out is that a median, however it's drawn either from B, C, or A, will bisect the area of a triangle. Okay, so just to show that, if I were to draw a median from B to this midpoint here, these two sides, these two areas would be the same. Any questions? Okay. Stop that.